This is SpaceTime Series 29, Episode 103, for broadcast on the 28th of August 2026. Coming up on SpaceTime, warnings that some Earth microbes could contaminate the Moon, maybe even Mars. Finally, success for China at its first reusable rocket. And Russia eyeing off the red planet as it develops its own nuclear rocket engine. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
NASA says some of Earth's microbes hitching a ride into space with human explorers could survive in shaded nooks and crannies at the Moon's south pole, contaminating the otherwise pristine environment. The findings, reported in the journal Science Advances, highlight the need to better understand microbial persistence in extreme lunar environments. Scientists are warning that as humans build a permanent presence on the Moon through the Artemis program and similar projects by other nations such as China and Russia, it may become difficult to distinguish ancient lunar chemistry from the contamination delivered by visiting astronauts. And that concern extends well beyond the Moon to the red planet Mars. The study's lead author, Prabal Saxena from NASA's Goddard Space Flight Center in Greenbelt, Maryland, says humans are natural explorers, and with them come their voices, their memories, and also their microbes. And for some scientists, that is unsettling. You see, people bringing microbes with them when they travel into space is unavoidable. The average human has, on average, 1 million bacteria living on each patch of skin the size of a pencil eraser. So these bacteria vent from spacesuits and habitats. Though the authors are worried about contamination interfering with the search for chemical clues to ancient geology and biology, they also argue that the Moon should be used as a natural laboratory. In shaded areas around the South Pole, scientists could carefully test the real-life limitations of microbial survival in an environment that can't be easily reproduced in the lab here on Earth. But before any surface science can happen, scientists need a baseline measurement of what contaminants humans bring. They'll need to understand what was there beforehand, because when they go to Mars to search for signs of life beyond Earth, they want to make sure it doesn't turn out being stuff they brought with them. And even with the strictest sterilization procedures, some organisms are stubbornly resilient. One good example is Aspergillus niger, a fungus that thrives in warm, damp places like household bathrooms and heating, ventilation and air conditioning systems. Astronauts have sampled this bug inside the International Space Station, and experiments demonstrate the fungus can even survive outside the station as well. Aspergillus niger is one of 5 microbes, including bacteria and fungi, selected for this study because they're known for their toughness in spaceflight environments. The very fact these microbes have survived in the vacuum of space was surprising. That's because these species are not considered to be extremophiles, which can survive in the harsh conditions in the vacuum of space. NASA geomicrobiologist Adam Regberg from the Johnson Space Center in Houston, Texas, says he would have expected the microbes to have dried out. He says NASA often bakes robotic spacecraft at temperatures above 200 degrees Celsius in order to reduce the number of living organisms on the item. But of course, that's not possible with astronauts. So contamination concerns take on a new meaning in manned missions to explore the Moon's South Pole environment. A clearer picture of where microbes might survive comes from understanding how sunlight behaves at the lunar poles. Now, survival for this study means the microbe can stay alive for at least one Earth day, which doesn't mean that it can grow and reproduce. Because the Moon has a very small tilt on its axis, the view from its poles is of a sun that appears just above the horizon, skimming the surface like a flashlight lying on a table. As a result, elevated parts of the surface, including crater ridges, mountains, and even small bumps, block light from reaching the lower-lying terrain. And this produces pockets of shadowed areas that can remain cold and preserve water, as well as shielding fragile molecules and possible microorganisms from lethal radiation. With that scientific context in mind, the authors set out to test which Earth microbes could survive extreme polar conditions. They focused on the sorts of organisms commonly found in spaceflight environments and those common on human skin. Besides Aspergillus niger, these included Bacillus subtilis, Staphylococcus aureus, Deinococcus radiodurannus, and several species of Fusarium. Based on previous studies, the authors noted the maximum amount of heat and ultraviolet radiation each organism can withstand. Then the organisms were tested in simulations of 3 regions near the lunar South Pole: Nobel Rim, Connecting Ridge and Djulaki Rim. These simulations used detailed environmental maps built up from elevation and temperature data collected by instruments aboard NASA's Lunar Reconnaissance Orbiter, combined with models of how radiation strikes the Earth's surface. The models showed maps of survivable niches that range in size from a kilometre-wide crater floor to an astronaut's boot print. Aspergillus niger, which was most resistant to ultraviolet radiation, was able to survive even in areas with some sunlight exposure. Now, usually ultraviolet radiation is so deadly to most microbes that it's used for sterilization in hospitals. When we think of the moon, we don't typically think of biology. But it turns out the moon is a place where a cell can survive, so our first exploration of these sites should pay extra attention to our microbial hitchhikers. And we need to work hard to characterize lunar chemistry before our visits change what we find there. This is Space Time. Still to come, China finally succeeds in landing a reusable rocket, and Russia develops a nuclear-powered rocket engine. All that and more still to come on Space Time. China has finally landed a reusable rocket in one piece. The Zhuqiu-3Y2 is a Chinese copy of SpaceX's Falcon 9, adopting as much of the American reusable first-stage booster's designs as possible. The Chinese mission was launched from the Dongfeng Commercial Space Innovation Pilot Zone in northwestern China. The facility serves as a key technology test site and launch complex used primarily by China's ever-expanding commercial aerospace industry. Following its launch, the Zhuqiu-3Y2 first-stage separation happened as planned 137 seconds into the flight, with the upper stage and payload then continuing to orbit and successfully deploying the Honghu 03 satellite. Meanwhile, the launch vehicle's first-stage booster returned to Earth and successfully landed at the Land Space Landing Site No. 1 in Gansu Province 6 minutes after its launch. However, after touchdown, leftover liquid methane and oxygen propellant suddenly ignited, triggering a fire which weakened one of the carbon fibre landing legs, causing the stainless steel booster to topple over, crashing to the ground. A less than auspicious end for what had been a successful mission. This is Space Time. Still to come, Russia develops a nuclear rocket motor, and the September equinox, and the constellations Capricorn, Pegasus and Cygnus are among the highlights of the September night skies on Skywatch. Russia has developed a prototype nuclear plasma engine which could cut journey times to the red planet Mars from 6 months to just 30 days, and they hope to have a full-scale version of the system operational by 2030. Rather than using conventional chemical rocket engines, scientists at the Rosatom-affiliated Trozisk Institute near Moscow claim their experimental propulsion system ionizes hydrogen into a plasma that accelerates these charged particles using powerful magnets. They say their 300-kilowatt prototype successfully accelerated plasma to 100 kilometers per second. Now, if successfully upscaled and integrated into a spacecraft, this continuous thrust mechanism could reduce one-way travel from the Earth to Mars to between 30 and 60 days. Such a dramatic speed-up would greatly cut astronauts' exposure to hazardous cosmic radiation and also reduce the amount of fuel and other supplies needed for the journey. With existing technologies, a manned mission to the red planet is likely to take 2 years, 6 months to get there, a year on the surface waiting for Mars to be in the right orbital position compared to the Earth for the return, and then 6 months to return to Earth. However, the Russian scientists behind the project admit there's still some major engineering challenges needed to be overcome before the system could be turned into a viable option for spaceflight. These include things like thermal control, long-term durability, and the generation of immense electrical power in deep space. The news comes as NASA is continuing to develop its own high-powered electric propulsion nuclear system, including a pulsed plasma rocket, which aims to cut travel times to Mars down to just a couple of months. Needless to say, we'll keep you informed. This is Space Time. And time now to turn our eyes to the skies and check out the night skies for September on Skywatch. September was the 7th month of the year in the old Roman calendar, which had just 10 months. That's before the addition of January and February. That 10-month year is still reflected today in the name September or septem being Latin for 7, October or octo meaning 8, November or novem 9, and December or deci meaning 10. It really wasn't until the Gregorian calendar that January the 1st marked the start of the new year, but in the beginning it was mostly only Catholic countries that adopted it. Protestant nations only gradually moved across, with the British, for example, not adopting the reformed calendar until 1752. Prior to that date, the British Empire and its American colonies still celebrated the New Year on March the 25th, marking the Feast of the Annunciation and Easter. The earliest recordings of a New Year celebration are believed to have taken place in Mesopotamia around 2000 BCE, around the time of the Northern Hemisphere vernal equinox in mid-March. A variety of other dates tied to the seasons are also used by various ancient cultures. The Egyptians, Phoenicians and Persians began their New Year off with the fall equinox, and the Greeks celebrated it on the winter solstice. While the Jewish New Year, or Rosh Hashanah, the Festival of Trumpets, occurs in September, where it marks the beginning of the Northern Hemisphere cycle of sowing, growth and harvest, and apparently the creation of Adam and Eve, according to the Jewish Bible, the Old Testament. The September equinox will take place at 10:05 in the morning of Wednesday, September the 23rd, Australian Eastern Standard Time. That's 8:05 in the evening of Tuesday the 22nd of September, US Eastern Daylight Time, and 5 minutes past midnight on the morning of Wednesday, September the 23rd, Greenwich Mean Time. The day marks the point in Earth's orbit around the Sun when the planet's rotational axial tilt means the Sun will appear to rise exactly due east to someone standing on the equator. It means almost equal hours of darkness and light. In fact, the word equinox is derived from the Latin, meaning equinus or equal, and nox meaning night. It all comes about because Earth's rotational axis is tilted at an angle of around 23.4 degrees in relation to the ecliptic, the plane created by Earth's orbit around the Sun, and Earth's axial tilt is pointed to the same direction in the sky, regardless of Earth's orbital position around the Sun. So on other days of the year, either the northern or southern hemisphere are tilted more towards the Sun. But on the two equinoxes, around March the 21st and September 23rd, the tilt of Earth's axis is directly perpendicular to the Sun's rays. For those in the northern hemisphere, it means the start of fall or autumn, while those of us south of the equator are moving into spring. It's also worth noting that the solstices and equinoxes change, and they're impacted by what's known as precession. That causes Earth's spin axis to wobble ever so slightly, sort of like the axle of a spinning top. Now, the rate of precession is only very slight, just half a degree per century, so you don't notice it on normal human timescales. But because the direction of Earth's axis of rotation determines at which point in Earth's orbit around the Sun the seasons occur, precession will cause a particular season, for example the Southern Hemisphere summer, to occur at a slightly different place on the calendar from year to year over a 26,000-year cycle relative to the planet's orbital position. At the same time, obliquity causes the angle of the axial tilt to change with respect to the ecliptic, that is, Earth's orbital plane around the Sun. Earth's obliquity, that is the tilt of the axis, is currently 23.5 degrees, and it's what's actually responsible for the seasons, and that varies over a cycle of roughly 41,000 years, between approximately 22.1 and 24.5 degrees. This axial tilt or obliquity changes due to the gravitational pull of the Sun, the Moon, and other planets. A higher obliquity leads to more extreme seasons, while a lower tilt results in milder seasons and can contribute to glacial periods. Then there's eccentricity. This involves changes in the actual shape of Earth's orbit around the Sun, sometimes making it more circular and other times more elliptical. This gradually shifts the point of perihelion, which is Earth's closest orbital position to the Sun. Now, these three effects, precession, obliquity and eccentricity, are collectively known as Milankovitch cycles, and they affect the amount of solar energy reaching the planet and have a major influence on climatic patterns. Okay, let's start our tour of the September night skies by looking towards the east and the constellation of Capricornus, the goat. The name comes from the ancient Greek tale about the demon Typhon emerging from a fissure in the earth and attacking Zeus, the king of gods, during a banquet. The sudden appearance of Typhon scared Pan, the flute-playing goat boy, who tried to escape by turning into a fish and swimming away. However, he realized his cowardice before completing the transformation, and so distracted the demon by playing his flute instead. And this gave Zeus enough time to use a thunderbolt from the heavens to frighten Typhon away. Because of his actions, both cowardly and brave, Zeus placed Pan in the sky forevermore, still in his half-goat, half-fish guise. The brightest star in Capricornus is Delta Capricorni, also known as Deneb-Algedi, or the tail of the goat. It's a near neighbour, located just 39 light-years away. A light-year is about 10 trillion kilometres. The distance a photon can travel in a year at the speed of light, which is about 300,000 kilometres per second in a vacuum, and the ultimate speed limit across the universe. Deneb-Algedi is a spectral type A white Beta-Lyra variable eclipsing binary. It's comprised of two stars closely orbiting each other. Now, astronomers describe stars in terms of spectral types, a classification system based on temperature and characteristics. The hottest, most massive and most luminous stars are known as spectral type O blue stars. They're followed by spectral type B blue-white stars, then spectral type A white stars, spectral type F whitish-yellow stars, spectral type G yellow stars, that's where our sun fits in, then there's spectral type K orange stars, and the coolest and least massive stars are known as spectral type M red dwarf stars. Each spectral classification can also be subdivided using a numeric digit to represent temperature, with 0 being the hottest and 9 the coolest, and a Roman numeral to represent luminosity. Now put all that together, and our Sun is officially classified as a spectral type G2V or G25 yellow dwarf star. Also included in the stellar classification system are spectral types L, T and Y, which are assigned to failed stars known as brown dwarfs, some of which were born as spectral type M red dwarf stars, but became brown dwarfs after losing some of their mass. Brown dwarfs fit into a category between the largest planets, which are about 13 times the mass of Jupiter, and the smallest spectral type M red dwarf stars, which are usually about 75 to 80 times the mass of Jupiter, or about 0.08 solar masses. As we mentioned earlier, Deneb-Algedi is a Beta-Lyra variable eclipsing binary system. It's made up of two stars closely orbiting each other. The total brightness of the system changes because the two component stars periodically pass in front of each other as seen from Earth, thereby blocking out the light from the other star in the system. The two component stars of Beta-Lyra are massive giants or even supergiants, so close to each other that their shapes are heavily distorted by their mutual gravitational forces. This gives each of the stars in the system an ellipsoidal shape with extensive mass flows from one component to the other. Just below Capricornus on the eastern horizon, you'll see the constellation Aquarius, the water carrier to the gods. Greek mythology describes Aquarius as the most beautiful-looking boy that ever lived, and so was carried from Earth up to Mount Olympus by Zeus in the guise of Aquila the eagle to become the water carrier. The two brightest stars in Aquarius are Alpha and Beta Aquarii, a pair of luminous yellow supergiants that were once spectral type B blue-white stars. The pair are moving through space perpendicular to the plane of the Milky Way galaxy. Beta Aquarii, the brightest of the pair, is also known as Sedal Sud. It's a multiple star system, located about 540 light-years away. The primary star is about 6 times the mass of the Sun, but emits roughly 2,300 times the Sun's luminosity, implying a radius at least 50 times that of our Sun. Beta Aquarii appears to have at least 2 faint companion stars, but you'll need a decent-sized telescope to see them. The second brightest star in Aquarius is Alpha Aquarii, also known as Sedal Melik. It's about 520 light-years away, around 6.5 times as massive as the Sun, and some 3,000 times as luminous. Next, we move to the southern constellation of Pisces Austrinus, the Southern Fish. The brightest star in the constellation is Fomalhaut, the mouth of the Southern Fish, and the 18th brightest star in the night sky. Interestingly, thousands of years ago, it was used to mark the position of the winter solstice, the sun's most southerly position as seen from the northern hemisphere. But the precession of the equinoxes, which we talked about earlier, has now moved the northern winter solstice to its new position in December. Located only 25 light-years away, Fomalhaut is a spectral Type A white-yellow star, about twice the mass of the Sun and around 16 times as luminous. It's also a really young star, only about 400 million years old. By comparison, our own star, the Sun, is some 4.6 billion years of age. Fomalhaut exhibits an excess of infrared radiation, indicating that it's surrounded by a circumstellar disk. It's also part of a triple star system, together with a spectral Type K orange dwarf star TW Pisces Austrini and a spectral Type M red dwarf star LP 876-10. Turning to the north now, there you'll see the constellation Pegasus, the winged horse of Greek mythology. Pegasus is the one who delivered Medusa's head to Polydectes, after which he travelled to Mount Olympus in order to become the bearer of thunder and lightning bolts for Zeus. The brightest star in Pegasus is the orange supergiant Epsilon Pegasi, which marks the horse's muzzle. Almost 12 times the mass of the Sun, it's bloated out to a spectral Type K supergiant nearing the end of its life. Astronomers are still debating as to whether it will end its days as a core collapse supernova or a rare neon oxygen white dwarf. Also in the north is the constellation Cygnus the Swan, which lies on the plane of the Milky Way galaxy. Cygnus contains the star Deneb, one of the brightest stars in the night sky and one of the corners of the summer triangle. It's also home to the giant Cygnus OB2 stellar association, which includes one of the largest known stars in the universe, MNL Cygni, a red hypergiant, about 1,183 times the radius and 50 times the mass of our Sun. In fact, were it placed at the centre of our solar system where the Sun is, its surface would extend out beyond the orbit of Jupiter. It's so big it contains a volume approximately 1.6 billion times that of the Sun. NML Cygni is located about 5,300 light-years away. Now, Cygnus is also home to Cygnus X1, a powerful galactic X-ray source which became the first widely accepted black hole. It was discovered back in 1964, and even today it remains one of the most studied astronomical objects in the sky. The black hole is estimated to have about 14.8 times the mass of our Sun, all crammed into an event horizon with a radius of just 44 kilometres. Little wonder black holes are the densest objects in the universe. Located just above the northern horizon this time of the year is the star Vega. It's the brightest star in the constellation Lyra and the fifth brightest star in the night sky. Vega has about twice the mass of our Sun. And it's a relatively young star, less than 500 million years old, and it's also fairly close, just 25 light-years away. Now, once again, due to the precession of Earth's rotational axis, Vega used to be the northern pole star around 14,000 years ago, and it will do so again in another 12,000 years' time. Just above Vega is Alpha Aquila or Altair, the brightest star in the constellation Aquila. It's a spectral Type A white-yellow star with about twice the mass of our Sun. Altair is located really nearby, just 16.7 light-years away, and it rotates very rapidly, with an equatorial velocity of about 286 kilometers per second, and that's a significant fraction of the star's estimated breakup speed of around 400 kilometers per second. Now, this high rotation rate means Altair isn't spherical, but highly flattened at the poles. Altair is the eye of the eagle that carried Aquarius up to Mount Olympus to become the water bearer for the gods. Looking to the southeast now, and you'll see the bright star Achernar. It's the brightest star of the constellation Eridanus the River. Located around 140 light-years away, Achernar has 7 times the mass and 3,000 times the luminosity of our Sun. The star rotates so rapidly it's elliptical in shape, with its equatorial diameter being about 56% wider than its polar diameter. September also sees the bulk of the Eurygids meteor shower, which is produced as the Earth passes through the debris trail left by the comet Kess C1911N1. Kess is a long-period comet, only reaching the inner solar system every 1800 to 2000 years. Its meteor shower runs between August the 28th and September the 5th. The Aurigids provide up to 5 swift and bright meteors an hour, with its peak just before dawn on September the 1st. It's best viewed from the northern hemisphere as its radiant, that is the direction the meteors appear to be coming from, lies in the northern sky constellation of Central Auriga. A second meteor shower in the month of September is the Epsilon Perseids, which run from September the 5th to the 21st. Although they're called the Epsilon Perseids, the radiant actually lies closer to the star Beta Perseus or Algol. Now, the Epsilon Perseids shouldn't be confused with last month's Perseids meteor shower. That's because while both appear to have their radiant in the constellation Perseus, they're caused by debris trails from 2 very different comets. And joining us now for the rest of our tour of the September night skies is senior science writer and Sky and Telescope magazine contributor Jonathan Nally.
G'day, Stuart. Well, this is actually a great time of year for stargazing. I really do love this season, because, especially for us south of the equator, because we have the fantastic constellation Sagittarius. We've got the centre of our galaxy overhead in the evening, best time for stargazing. And we've got the summer constellations beginning to appear in the morning sky. So we're getting a good mix of both winter and summer viewing. So let's start as usual with the Milky Way and the constellations. So at mid-evening, we've got the Milky Way, which is our home galaxy seen from the inside. It's stretching right across the sky from north to south. Now, you do need dark skies to see it. If you're in the city, you're probably not going to see the Milky Way, unfortunately, because it's quite pale. But if you're out of the city, in the country, or you can get away from lights, so you might be able to see it. Certainly you'll see it in the country. So for those of us at temperate latitudes, sort of mid-latitudes in the southern hemisphere, the centre of the galaxy and the star fields of the constellations Scorpius and Sagittarius are more or less directly overhead, at least far from where I live. And Scorpius, incidentally, is one of the few constellations that looks like the thing it's supposed to represent, a scorpion. Someone showed me a picture they took on their phone the other night, and they just said, I just took a picture of the sky, first time taking a picture of the sky. And I said, oh, well, there's Scorpius. And she said, where? And I said, I just traced out the line. She said, oh, yeah, I can see the scorpion there. So it's big, and it's a huge constellation. It's not a tiny little thing. So no wonder people perhaps don't see it at first. But once you see it, you can't unsee it. You will always know how to recognise Scorpius. And the whole region around there is really great to explore. You can spend hours over multiple nights just sweeping back and forth through this area with a pair of binoculars or a telescope, particularly a telescope that's got a wide field of view. There's so much to see, an endless list of famous, what astronomers call deep sky objects. You've got the Lagoon Nebula, you've got the Trifid Nebula, you've got the Eagle Nebula, the Hubble telescope got the famous picture of the Eagle Nebula. You've got star clusters like Ptolemy star clusters and the Wild Duck star cluster, because it looks like a flock of ducks, all sorts of things. Do try to get away from any sources of light pollution if you can. That always helps when you're doing stargazing. Way down south, we've got the Southern Cross lying on its right-hand side. The 2 bright pointer stars are above it. And if you have really dark skies and you let your eyes adapt to the dark, see if you can spot a dark patch just next to the Southern Cross. This is a huge cloud of dark dust and gas floating in space called the Coal-Sack Nebula. And it really does stand out. If you're out in the middle of nowhere and you've got really dark skies and you let your eyes adapt to the dark, then you'll definitely see the Coal-Sack. It's like this big black patch next to the Southern Cross. And you get a telescope onto that and sweep through this nebula, you'll see that there are some stars there between us and this huge nebula, and the nebula's blocking all the stars that are behind. In the old days, we'll call it the old days, when astronomers were still investigating these things, no one really knew whether this big dark patch next to the Southern Cross was a hole. We were looking all the way through this hole out through a gap in the galaxy out beyond, or whether it was what it has been found to be, a big floating nebula that's blocking the stars from behind, with a few little stars in the foreground. Anyway, that's the Coal-Sack. And just near the left-hand star of the Southern Cross, that's at the moment, that's the one that's uppermost in the sky, there's a little cluster of stars called the Jewel Box. And even a pair of binoculars will show it really well. It has a really pretty collection of stars of a variety of different sort of colours. Most star clusters, they generally just have like white stars or blue stars, but this one's got a whole collection of really nicely coloured stars. Now, as the night goes on and the Earth turns, the stars will appear to move towards the west, some going below the western horizon and others coming up in the east. By midnight, the Milky Way is now low in the west. It was north-south, sort of straight across the middle of the sky, north-south in the early evening, but by midnight or so, the Milky Way is now low down in the west because the Earth is turning the other direction, and the Milky Way will dip below the horizon. But the eastern part of the sky, even though it will seem a bit bare through till about 1 o'clock in the morning, then some other constellations are going to start to rise, including the fabulous Orion constellation that we talk about a lot. And when you see Orion start to come up in the night sky, you know that the seasons are changing. So for us in the southern hemisphere, seeing Orion means that summer months are on their way, not too far away. And for our friends north of the equator, it means that winter is on its way as well. And in the hours before dawn, you'll see, if you're up that early or up that late, you'll see the constellations Taurus, Gemini there, very close to Orion too. Taurus has got this wedge-shaped cluster of stars called the Hyades, and Gemini has a very small but very prominent star cluster called the Pleiades, which is the Seven Sisters. And I have a really soft spot for both these constellations, as they were some of the first I identified and studied when I was a teenager, using just a pair of binoculars. All I had was a pair of binoculars. I had my mum's binoculars. I think they were 8 by 30 binoculars, very small. And I had the old star chart that came out of an issue of National Geographic from the 70s. It was a famous star chart, not really intended for use in stargazing because of the way it's drawn, but I managed to figure out some of the constellations just using this old star chart. I wish I still had it. It'd be worth a mint now, I reckon, an original one of those. Anyway, that's the stars and constellations things. Let's have a look now where and when we can see the planets this month. And the month actually starts with a bang because we've got Venus appearing very close to a bright star called Spica. They'll only be about 3 moon widths apart in the evening, just in the first couple of days of September. You'll see them about halfway up from the western horizon. I mean, you won't miss Venus. It's big and bright, and the star that's right next to it is called Spica. And as each night passes, Venus will gradually separate from that star and climb a bit higher in the sky, or the star might be getting a little bit lower, or both. And Venus will be joined by the moon on the 15th, very close to the moon. So that should be another very pleasant sight. And in the second week of September, you've got the innermost planet Mercury. We'll be able to see that low above the western horizon after sunset, little bright star-like thing, climbing higher each night. So by the 19th of September, it'll form a nice, straight, equal, even line with that star I mentioned, Spica, and Venus. So it'll go Mercury, Spica, Venus, going up from the horizon. And on the 26th, Mercury, because it's moving through the night sky, it and that star Spica will appear even closer together than the Venus and Spica appearing a few weeks earlier, only about 2 moon widths apart. And then as the month ends, we've got Spica, Mercury, and Venus will all be in the same part of the sky, forming a nice little triangle above the western horizon. The next planet is Saturn, which will rise above the eastern horizon about 8:30 p.m. local time at the start of the month, and it'll just get higher and higher each night as the weeks go by, up above the eastern horizon. The other 2 bright planets, Mars and Jupiter, can only be seen in the morning sky before sunrise. So you've either got to be an early riser or very late getting to bed. Mars is rising about 3 a.m. in the northeast, with Jupiter following about an hour later. And it's interesting to compare the two because Mars looks really small and dim compared to Jupiter. So to the untrained eye, you'd think that, well, it looks smaller and dimmer, it must be further away. But it's not. At the moment, Mars is about 251 million kilometres from Earth, whereas Jupiter is about 890 million kilometres away. So that's more than 3 times, 3.5 times further away. But the reason Jupiter looks so much bigger and brighter, even though it's further away than Mars, is that Jupiter is bigger and brighter. It's a huge planet. It's a gas giant, whereas Mars is just a tiny little ball of rock, even smaller than the Earth. And finally, down here on Earth, we're going to reach the equinox on September the 23rd. So in some parts of the world, this date is considered to be the beginning of the relevant season, so either autumn or spring, depending on which hemisphere you're in. And in other parts of the world, it's considered to be roughly the midpoint of the season. So September 23rd this year, so our friends in most countries in the Northern Hemisphere will consider September 23rd to be the start of their autumn. For us, September 23rd, we consider it to be the rough it's not really the midpoint, but rough midpoint of spring. That's just the way we decide to do it because we base it more on meteorology than the actual dates. In other parts of the world, of course, such as the parts of the tropics, those sort of seasons, autumn and spring, they don't have much relevance, of course, because a lot of the tropics, they just...
It's wet or dry. It's that simple. Yeah. And in Darwin,
you've got the dry season, you've got the dry season, which is not really very dry, and then you've got the wet season, which is like monsoon, is really, really wet. So equinoxes don't really come into play much there. I mean, it's still the equinox. It's when the sun's crossing the equator, but in terms of meteorology, it doesn't quite apply to about 50% of the world's population. They just have wet or dry, a bit like sandpaper. But anyway, Stuart, that's the night sky for September.
That's senior science writer and Sky Telescope magazine contributor Jonathan Nally, and this is SpaceTime. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from SpaceTimeWithStuartGary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies. or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.